The battery's electrical energy is produced between the active materials of the metals when they are placed in a solution of sulfuric acid and water. This solution is called the electrolyte. The electrolyte is a solution of 36% acid and 64% water by weight. This electrolyte has a specific gravity of approximately 1.27, in between that of water at 1.0 and pure sulfuric acid at 1.835. When charged, the positive and negative battery plates each react with the sulfuric acid in a unique way. As the sulfuric acid reacts with the active material in the plates, a difference in electrical charge between the plates is created. When the battery discharges, the sulfuric acid solution weakens, and after a period of time, no further reaction takes place. But when current is applied to the battery, the reaction is reversed, and the sulfuric acid can be restored to its former strength. This is why an automotive battery is rechargeable. The battery converts incoming electrical energy back into chemical energy. Automotive batteries are sometimes called storage batteries. Energy is stored within the chemical makeup of the electrolyte and plates. The battery uses the creation of positive and negative ions to store and release electrical energy. Let's look at what ions are and the role they play inside a battery. Under normal conditions, the atom contains an equal amount of positive and negative electrical charges. It's possible to upset the balance of charges to create an atom that contains more electrons or fewer electrons. An atom with more electrons is a negative ion. An atom with fewer electrons is a positive ion. In a normal state, the electrolyte will tend to divide into positively charged hydrogen ions and negatively charged sulfate ions. These molecules, while electrically opposite, will match each other and produce no electrical activity. But if lead plates are placed in the electrolyte, the acid in the solution reacts with the lead in the plates. Electrons are pulled away from the positive or lead peroxide plates and move through the electrolyte to the negative or spongy lead plates. Over time, as the battery discharges, the reaction becomes weaker as more of the solution is converted into water and lead sulfate forms on both positive and negative plates. The ratio of water to acid will change until, in a discharged battery, the electrolyte is only approximately 17% sulfuric acid and 83% water. As the battery discharges, electrons leave the battery by the negative terminal. But in charging, the electrons are pulled away from the positive plates and forced back into the battery through the negative terminal. The force that does this is voltage. This charging and discharging process can occur many times. However, the battery does not last forever. As the battery discharges, the plate material expands slightly. On charging, the material contracts. This charging and discharging is called a cycle. Cycles tend to cause the plate material to loosen and flake away from the grid. Eventually, the battery plates crumble and the battery must be replaced. Batteries last longer if they're kept under charge. There are advantages and disadvantages to maintenance-free batteries. The maintenance-free battery tends to have a greater resistance to overcharging, a longer shelf life, and higher cold cranking ampere ratings. The disadvantages of the maintenance-free battery include a possible shorter life expectancy, difficulty in recharging if completely discharged, and an inability to withstand deep cycling.